present myself. So, welcome again. You are now in this boarding of the Microservices lectures or class winter term 2020-2021. My name is Albert Zundorf. I'm located at University of Kassel, and we have set up quite some studio here in order to give this course. So Germany has a corona-based lockdown these days. So our university is actually closed. So no student is allowed to come into the university. Actually, Eric is cheating. He is sitting in the university, and but he's a special student. And but Jan is actually at home. Are you Jan? Yeah. So I actually have a big screen here in front of me where I have the Zoom session in a gallery mode. So I can see all of you. I see all your camera pictures, and we will use this to make this lecture as interactive as it is possible. So from time to time, I will ask you for some reactions. So raise your hand, or please, those of you who have a computer in front of them, go for these, open your chat and just send me a short message. Yes, I can do that. Or a hello in the chat of the Zoom, so that I can see that you are attending and that you are not sleeping, and that this is going to work. And the other ones, please, at the bottom of your Zoom, there's this bar, toolbar, and there's reactions, and you can click on those reactions, and then you get some icons in your picture, and I can see that things are working. Please, would you try that? Okay. Yeah. Yeah, please, go on. Take your time. So, is the sound okay for Douala? Who can hear me? Raise your hands. And who is? Yes. Oh, the back rows have little problems. Okay. So we need to improve on that. Actually, the lectures. Yeah. So you can actually join this lecture also with your smartphone. Who doesn't have a smartphone? Just go through the Zoom link. It's just that you can have a camera. Then I can see your face, and you can speak to me. And you can give me your reactions. Yeah. Yeah. So, cool. So I actually scheduled this boarding session because, well, I'm usually giving this course to the students at University of Kassel. And those students at University of Kassel usually already have had a lecture with me last year or last term. So I know these people pretty well, and I really know what they have already done in their previous lectures, what they already can do, which programming languages they do, and, well, actually a lot about their settings. Also a lot of our cultural setup and mindset. So it's the very, very first time that I'm speaking to people from Douala. And, well, actually, no, that's not true. I know Eric, actually. He came over from Douala to University of Kassel, did his master's in computer science here, has recently finished his master's thesis. Congratulations to that one. And he was actually talking to me and says, "Oh, Albert, your lectures are so very practical. And in University of Douala, We have a lot of good things in theoretical computer science, and it's close to the math department. But practical lectures, as you do, we are having not enough. And it would be so great if you could go to University of Douala and just present some of this stuff over there. And actually, this was about 2 years ago when Eric approached me with this idea. And I said, okay, yeah, we can really do that. And I would actually love to do that. And Eric said that if you do a good lecture to these people in Douala, many people of them will come over to Kassel afterwards and do your master's thesis in Kassel, or come over to Kassel and do some studies. And so I have learned that University of Douala has a lot of students. That is not true for University of Kassel. University of Kassel has about 130 freshmen per year in computer science. 130. And we have enough professors to teach 300 students a year. And so we have just half the students that we should have. And so we have a lot of free places for you people to come over. And that's actually the idea of how this has started. So when we were thinking about, what would be a cool thing that I could actually present to the people in Douala and go over, actually, the plan was I would come over to Douala for some 2 or 3 weeks and give a course at your site. And then there was Corona and no, we couldn't go. And therefore, we said, okay, students from Kassel can no longer go to the lectures. We do the lectures online via Zoom, and then there's no reason why shouldn't people from Douala not join us? And then we can have this as a common course for both universities. And that's actually what we are trying to do these days. Okay, cool. More people from Douala. Great. Welcome. Today, I would just like to, establish a common ground with you people. I need to know what is your skills that you already do have? What does your equipment looks like? How do we speak to each other? Is the internet connection actually working? That is a big point for us. And these kinds of things. Great. Thank you for muting Light Orochi. I first of all have to apologize for I really struggle to pronounce your names right. So I'm pretty good at names like Eric, but Niakam is already pretty hard for us. Actually, your country is really rich on vowels in your names. That's so cool. So we don't have that. And please, I'm so sorry. I try my very best. I can do phono, I can do band, but Rochi, it's already hard. And there's Frank, yeah, Muanji. Muanji, yeah. So it's pretty hard for me. I also have to apologize for, I cannot give this lecture in French. Je ne sais pas parler français. Sorry, I really cannot do that. So we have to do this in English. That's basically the point. So I have a lot of questions that I'm going to ask you pretty soon. And so please prepare to give me some feedback on things that you already know. And some of the stuff that, so this is now my slides here. Welcome to this talk here, our lecture today. It's about microservices, and I will today explain what this means actually. And so my name is Albert Zündorf, or Albert, or whatever you want. That would be fine for me. And I'm going to do this together with Sebastian. Sebastian, would you say a word? Ooh. Yeah. So Sebastian is actually a PhD student of mine. He's working with me together for 2 years now, and his PhD is actually on this topic of microservices, and we are having promising results in this area. And he will actually help me in actually doing all these lectures. First of all, this is not a typical lecture. In University of Kassel, this is announced as a lab, so a laboratory session. And the idea is that we do this hands-on. So I really hope that by next week or something like that, each and everybody of you can show up with his own computer or her own computer. The idea is that we do program together. I will actually do some programming. I will do so today. And at the end of some 2, 3, 4 lines of code I have shown you, I will ask you to do the same thing on your computer. And then I will actually wait until you have achieved the same thing. And you say in the chat, oh yes, I have done it, or no, I have a problem. If there are problems, we are trying to go into breakout rooms in Zoom that we have a bunch of teaching assistants who are going to help you on the topic. And once we have all accomplished a certain step, then I go ahead with the next step. And again and again. And at the end of the term, we will have created a pretty great microservice application. There are a lot of question marks in your faces. So Eric is pretty skeptical. The team HP doesn't believe that it is possible. Rodrigo, do you think this will work? Raise your hand if you like. Oh no, the picture is frozen actually. Yeah. And so today I will actually. Yes, there's some mic on. Oh, the of Ben. Ben Mafu. Do you have a question? Yes, but would you mute your mic? So otherwise, we have a feedback loop. Yeah. Oh, great. At least we can interact. That's cool. Okay. So that's basically the idea. In addition, we will have our screen recording of this whole session. So when you lose contact or you cannot keep up with the lecture or with the lab session, you can actually do that later on. Then you can watch the video and then try to do it anytime. So Eric, you are so skeptical. What's up? Can you hear me? You're muted. Okay. Okay. So I actually do a videotape of this, and we will publish this videotape on YouTube. Who has access to YouTube? Who did ever see a video on YouTube? Yeah, some more. Rodrigo did never see a YouTube video. Team HP, some of them they did. Okay, so you can actually watch it, and you can actually do it in your own speed and step by step and go through this. Once a week, every week, we will ask you to show us your achievements. So you actually would come to such a Zoom session, then we will have breakout rooms and we will do you one by one together with a teaching assistant, with a guy at our side. And then you demonstrate the program that you have programmed over the week. And then you get grades for this demonstration. So you show, okay, look up, this dialogue is working. This screen here, here's this operation, and it's working as you intended. We will have a look at this. You get points for this. And we will do this every week, usually in front of the lectures, half an hour. You demonstrate your homeworks and you show us how it is working. And then we give you points, and the points will sum up over the week, over the whole term. And at the end, you get a grade based on these achievements. So there will be about 15 assignments, perhaps only 14, something like that. There will be 5 assignments in the first 5 weeks where you get 10 points. There will be 5 assignments in the week 6 to 10 where you get 20 points. And there will be 5 assignments with 40 points, so the big point at the very end, because functionality becomes more complex after some time. If you show us what you have programmed and we are saying, no, it's no good, you need to improve something, or there's functionality missing and there's more that you need to do, then you have the chance just to repair or to fix your program and show it to us again. Some days later, we appoint and then we look at it again and say, oh yeah, now it's good. And you can still earn the credits. So if there is on the first show, it doesn't work everything, then we give you some tips, you fix it, you show it to us again, you get the full points. That's the idea. The thing is that all these assignments build one upon the other. So there is no way that you say, oh, this week I'm not going to do it, and I skip this assignment of this week. Then the week after that won't work anymore because it will build upon the week before. And therefore, it is really important that you manage to complete each assignment. And if you take some more days or for it, that's not a problem. But to start with this next assignment, you always need to finish the previous assignment. Is this okay for you? So great. So we have set up a Discord, which is something like a communications thing that we want to use within these lectures in order to have more discussion and more interaction probabilities. So I would ask each and everybody of you to download Discord, have a Discord account, and join us here in this thing. Does it work? I don't know. So this says, oh, I have to download it again. I'm not going to want it. Do I? Oh, yes, this is the Discord. And this is a microservice thing. I have actually seen some people coming in here that have already achieved to go into our Discord thing. Actually, if you didn't see this link that I have used, let's go back here. Yeah. Okay. So please ask. Could you put your question into the chat? So the sound was very bad and I couldn't get it. Just write it in the chat, that's easier. Okay, take your time. Yeah. Very good. So for those who did not yet find this, you Google for, can you see that? Okay, you Google for Software Engineering University of Kassel, Germany, and that should actually bring you to the blog of my research group. And there you can go for microservices, and there for lecture preparations. And there you will find also this link to the Discord. There you also find the link for the Zoom, how to go to the lectures. We will have some slides here and these kinds of stuff, but we will also publish a lot of things in the Discord. So please try to find these entrance to the Discord, and then we will have a lot of discussions for it. There is a question now in the chat there, I can see it. If there are any problems with the assignment, can you ask for help at the Discord? Yes, you can. That's actually what it is good for. So we will also be on the Discord, and if there are any questions, we can actually help you. You can actually also have a direct chat with some of the teaching assistants that are going to help you. And we will also do a lot of interaction with you in the Discord. Very good. Okay. I will also put these slides, the link to the slide somewhere. It's probably already here. Yeah, it's also reachable here. If you click on that, you can actually try this now. You should get actually access to my slides. And the good thing about this, these are Google presentations. You can actually work on these slides with multiple people in parallel. And the idea is that I can actually leave my presentation, and I can actually type on this one here and actually say, oh, you need to do an npm install with templates and these kinds of stuff. And the idea is that you can actually enter my slides and copy paste such pieces of code from the slides and put it into your computer. So you do not need to retype all the stuff, but you can actually do it directly. You can copy paste it from my slides. So therefore, it's a very good idea when the lecture starts, you have your Discord ready, you have the Zoom ready, and you have those links to the slides so that you can actually go into the slides and do this. So one has already done it. So the anonymous Gürtel here has actually managed to go and reach my slides. Please exercise this a little bit because this is actually very helpful in lab sessions that you can have code examples. Yeah, how to get access to the slides. You have to go back to, come on, Google for my group, Software Engineering University of Kassel. Can you do that? Please do so. And then, well, there is a link saying Software Engineering Research Group, Kassel, Germany. And if you go on that one, who did that? Keep your hand. Who was able to find that? Cool. Damlabin, did you do that? Yeah, cool. Then I go for microservices. So it's a current term. Microservices. Yeehaw. And then for some reason you need to open the lecture preparations. Who did that? Cool. And then you can go for the slides are available here. And this will put you, hey, there are 2 people now. Someone managed to do that. Yeah. Oh, yes. Number 3. Very good. Great. Yeah. So, and if you then go to the, we actually share these slides now. And if everything is right, I am able to write on these and you are able to copy from these. And so just let's try that. Try to take these line here and put it into the chat, please, of the Zoom or into the Discord. Or put it in the chat. That would be great. And then you can see that it did work. So take your time. We are not in a hurry. Just go there, try to grab this line of code and put it in the Zoom chat. We just wait until you have achieved that. Yeah, who's first? Hey! Eric, you're cheating. You did that before. And there's another one. Ah, yeah. Oh, that's a good idea. Thank you for putting the Discord link there. And perhaps I will also put the link to the slides in the Discord. Yeah, Sebastian, can you join? Let them in. Yeah, and put it in the Discord in too or everywhere. Yeah, cool. Okay, let me go back to the Thingo. There are 5 people which have managed to go into my slides. So I see some 3, 4, 5 here. Could you please go to slide number 4 and then try to copy this thing here and put it into the Discord, into the Zoom chat. Oh my God, that would be great. Yes, yet another one. Pretty nice, very cool. I love it. Great. Yeah. Very great. Yet another one. Cool. So, yeah, that works. I love it. Let's go ahead a little bit. what are you going to learn in this lecture? So who has an idea what a single-page web application is? Anybody? Just raise your hand if you say, I have heard about this word before. Nobody? Has anybody an idea what a web application is? Yeah. Okay. 2, 3, 4. Okay. Okay, yeah. I will try to find the French words for these things in the next days. Thank you for raising your hands. So let's go for that. I go back a little bit in history and explain a little bit how these programs are working these days. And so here, this is a kind of diagram that I'm going to use frequently during this course. And there is Alice. So this is a pretty typical example for some student who has started her computer and has started her browser. Anybody knows what a browser is? Web browser? Hey, cool, that works. And she was visiting a certain website. Okay, and so here we have a little backup. So Ben Mafu, could you mute your microphone? Yeah. So you have to mute you. Yeah, thank you, sir. So when you open your web page or your web browser and connect to a certain URL, to a certain link, then you actually go to another computer where a web server is running. And this web server has a name. Well, actually, the computer has a name, which is all the thing before the first slash. So www.x.com is actually the name of some of the computers or the server that you are connecting. And then you ask this server to send you the hello thing. And actually what this server is going to do is it will look for a file. So this is static content. This was technology used in the 1990s, so last century. And it will go to the disk and in a certain directory, find this file, read this file, and bring back to you the content of this file. So it will send back to the browser an HTML, hypertext markup language description. So these are HTML structures. Who knows HTML? So everybody knows it. Great. So we can go on here. You get a file with these markers. They are always matching. And it actually has here an H1, which is actually, I have no idea what the English word for Überschrift. It's header. It's header size 1. And then your browser is actually reading all this and making a nice presentation of this. Reading the HTML and then doing or creating a screen representation of this is called rendering. And this is what your browser does when you send it such a description. And then you get a nice big header with hello world on your screen. So that's 1990, some 30 years ago, are the techniques that we used at the very starting points of the internet. And then the next thing is we wanted this a little bit more active or dynamic. We wanted more dynamic content in our web pages. And the step after delivering just prepared files was that we prepare the HTML file, the content that is going to be shown at the server in the moment that somebody asked for it. It is called server-side rendered content or the pages. And there's a lot of technologies that do this for you. What we have here is that Alice has entered her name and some login into a dialog here and presses OK. Then there is a special request going from the browser to the server saying with extra parameters. So what Alice has entered here becomes part of the URL, Unified Resource Locator. And well, actually what we do is we want the login page. We want it with a question mark. And then there is the parameter login has the current value Alice 42. Then there is an ampersand. And the name parameter is Alice. So the clear name is Alice, the login is Alice 42. And we send this request to our server. The server says, okay, you want login. I go for the start HTML file on my disk. There should be a laser pointer. Hey, cool. I go here. Come on, go away. This bar is in my way. And actually, in this disk now, there is not just a plain static HTML file, but it's a so-called template. It has these special marker. If you read down there in this disk box, it says hello, and then curly braces open, yet another curly braces open, name, curly braces, closing, closing. This is the so-called template. So it's text containing placeholders that shall be replaced by dynamic content. And actually what is happening is that here, still at the server side, there is the server actually running a program searching for such placeholders and replacing them with dynamic content. So what is actually happening is it is looking for these curly braces and the name. Says, okay, name, I just got it from Alice. So I replace this curly braces here, or this placeholder here, with the name Alice. And put this in the whole file. And so I send back hello Alice to my browser. Everybody happy with this? Who didn't know this before and is actually bored to death? So who did already learn something? Okay. Give me some reaction in Zoom. The sum up would be great. Is this all clear? Yeah, there's at least one thumb up. Great. Okay. So now we come to a single page web application. And actually the idea is that take a template and replace these placeholders with dynamic content is happening at the browser and not at the server anymore. So the idea is that well, Alice is still entering her data. We do send this data to the server, but the server is not going to respond with the new page that has to be shown, but actually just stores this data locally in a database. So this is the table at the bottom of this slide. And if you then go to another page, you do this at the browser side. So at your computer at home, you actually say, okay, I would now like to switch to the welcome page. Then we send a GET to the server where we actually ask, so what was actually the name of the user which is currently logged into our page? So we say, oh, could you please send us the name for Alice42, the full name or the real name? We go into the database, fetch the name, and we answer just with this value here. And here, this is JSON notation. So it is a simple textual length. Who knows JSON? Anybody who knows JSON? Yeah, more people who know JSON, very good. So it's the JavaScript object notation, and it is a textual notation that is very simple, that allows you to encode data to send over the network. So this is just an object with a single field, and the value of this field is Alice. And so, provided with this data, then we can render the welcome page, which is actually, or create a welcome that shows Alice, and this actual replacing of placeholders and creating the final HTML that then is shown to the user is done in the browser of Alice. So what we actually did is, during the last centuries, or last decades, sorry, not so in the last 10, 15 years, we were pushing a lot of computation from the server to the client. And so finally, these clients become full programs that can do anything that the server can do too. And thereby, our pages become much more powerful. So the Google presentation that I give to you now, so my slides actually are actually running with the Google presentation things, and this is a single page web application too. So actually the whole mechanism that we have here is working in a way that it really gets the content of the slides, or show a square, show this line of text from the service, from this Google server, and then it creates the image on the client side. So within my browser. That was a little bit complicated. Okay. So what is a microservice? These applications grow in complexity, and they become more and more complex all the time. And so what we have is we pushed a lot of functionality that were in the server to the client. Thereby, the server gets a lot simpler to be programmed. But still, the functionality a single server has grows and grows and grows, and they become more complex all the time. And then, from a software engineering point of view, so I'm a software engineer, if your program grows beyond a certain limit, then you need a lot of people to actually, develop or maintain or do bug fixing on this big program. And if your team is larger than some 20 people, it becomes really, really hard to work with so many people on a single program. And finally, your program will break down. you are no longer able to actually develop new functionality to enhance your program any longer. And the idea is that you split your big program into many smaller programs. And you have a group or 3, 4, 5 small programs, and each of these programs is maintained by some 10 people. And thereby, everything is much easier to manage, the projects are much easier, and it's much easier to fix bugs and to implement new functionality. And therefore, we do this for web services or for web servers too. So what we do is, instead of using just one web server, if your whole application becomes very, very big, you just use multiple web servers. You split your web servers into multiple of those, and then you connect those different servers again by sending messages from one to the other. And if you do this, due to the poor complexity of your service, you split it a big monolithic service into multiple smaller services, then you have a microservice architecture. And it turns out that a microservice architecture is a very good idea in order to develop large web applications in an agile, iterative manner. And if you do not do that, you will run in a lot of problems. So in Germany, at least, or most parts of Europe, I do not know about Cameroon, and most big enterprises run on SAP. SAP is a program that it's an enterprise resource management system, and it's actually does all the administrative thing in your big enterprise. So if your name is Volkswagen and you are producing cars, then every single production step is actually organized by SAP. Every ordering of material, of parts, of anything is done via SAP. Every payment of Gehalt. So employing people is all organized, and pay them their monthly money is all done with SAP. And this results in a really complex application, which is really hard to manage. And if you do want to reorganize something in your organization, in your enterprise, it is really hard for big enterprises to run on this single thing. And the idea is actually that we overcome this idea and that we go down to smaller things, run by smaller teams, and that we are able to change things more agile, to develop things in more modern ways, iteratively, with smaller costs. So the idea for this lecture is a little bit that if you are living in Cameroon and you would like to start a small enterprise, then you could actually take the techniques from this lecture and run the enterprise with this software that you are going to develop through this course. So what we actually will do is we will set up in this course a small shop, an online shop, where you can buy some goods, food, shoes, cars, refrigerators, I have no idea, bikes, anything, and then it is going to be delivered to you. So who knows Amazon? Do you have Amazon in Cameroon? Yeah, everybody has Amazon. So we actually would like to, no, not everybody. We don't have it, but you know it. So yeah, so you should build one. So the course goal is just build Amazon for Cameroon. That's the point. Yeah, that's actually what we are going to do. So that you can have it at your site. And we will have, well, actually, we will start with 2 services. We will first set up an online shop where you can actually buy stuff. And we will have another service, another computer, another server, who is actually, which is doing all the delivery, so handling of goods. There will be a big warehouse where goods are stored, and then there will be orders coming in, and then you will actually go to the shelves, pick the goods, and then deliver it to the customer. You have delivery services. So there is a postal service where you can send packages around in Cameroon. Would that work? Eric? Yes, of course. So cool. So we could do that. Or we could have a third service where we actually do this delivery and then organize that one. That would be also a nice idea. Okay. So what I would really like to do, we have one more thing I would like to explain to you. So scaling. Software engineering is a lot about how to start with a small program and then come to a big enterprise that is running on that program. And the idea is you can scale in, well, various directions. So first of all, software engineering scaling means actually, I start writing a small program just for myself or for my teacher. And then I say, okay, I want more users. So you can scale actually in the number of users that you have. And some 10 users, no big problem. You go from one to the other, explain them how to use the program, they are happy with it, it works great. If you have 1,000 users, you cannot actually go to each of everybody and sit together with each new user for 1 hour, because it would use 1,000 hours in order to come up with, to just explain it to everybody, and this would cost you a whole year if you're alone. So that's not working. And then you need actually documentation. You need introduction, you need guided tours, you need tutorials how to use your software, and these needs to be developed. If you have 1 million users, then you need to support different programming languages, different languages. You will have a French version, an English version, whatever, a Spanish version, a Chinese version, and these kinds of stuff. There's more effort to be done in that direction. You can actually scale in the data you are handling. As long as all the data you have fits into the main memory of your computer, some gigabyte or something like that. That's a very easy thing. As soon as you need more space, you have more data than, let's say, 1 terabyte, you actually need to go down on your disk and write it to persistent memory. You need a database after all. If you have some petabyte, a single database server wouldn't be enough anymore, and you need a distributed database. And that is a whole new world of techniques that you actually need. And it goes on in this direction. So the computer science has actually developed quite a number of techniques to scale in the number of people that we can help and the amount of data we can deal with, or the amount of requests we deal with. And one very simple, the very first technique that you use is scaling in x-axis, which is you just deploy your server multiple times. Instead of just having one computer, you have 100 computers. And each run the same program. And offers the same functionality. And then when a browser request comes in, you just send the first request to the first computer, the second request from another user to the second computer, and so on and so on. If most of these requests are just reading some data, that works very well. Writing of data becomes more expensive because if one of these guys adds new data, you need to put that into the database, and all the other servers need to get knowledge of that and then get this data from the database again. So what you first do is you have just one database and 100 servers that access the same database, and the database actually organizes the parallel access. That's a very simple thing that you can do. What you also can do, if this does not work any longer, you can partition your data. You can say, I have a shop with 1 million products, and all the products from A to M, where the name starts with the letter A, B, C to M, is going to work on this computer. And all the products that are from N to Z are living on the other computer. And then if Alice wants to buy shoes, you say, oh, S for shoe is in the second half of the alphabet, so it's going to that computer. And if someone else buys a bike, oh, that is on the first part. And therefore you have actually split the load of the incoming requests on two computers by partitioning your data. That's one idea how you can do that. You can also, partition by, so I understand Cameroon is speaking French and English, and then you could actually say, oh, I have one computer serving English customers or English speaking websites, and another one serving French speaking websites. And that are other people, things that you can do. Okay. And finally, you can actually say, okay, I do this partitioning here. I split the functionality up. I say I split between shop and delivery. I say these are two different things, and I put that on different services. And if you do the later thing, if you split functionality, then you do microservice architecture. So there seem to be some technical problems. I just give Mr. Fono some time to fix it. Is it working now? Yeah, great. Cool. So, what we really want to achieve is that you learn in this lecture how to develop a web application that is supporting a pretty complex workflow. Some order is coming in, you pick all the things that have been ordered, pack a package, you deliver the package. So that's a pretty simple one. It could be more complicated. But you would like that for any small enterprise that you would like to support with your software, you can actually, all the work that is done in this enterprise, support with your software. And this might be distributed on multiple microservices because this is a pretty modern architecture that will allow you to provide this software in an agile manner, which is says, oh, this week we developed this first microservices and you can already use this. And you have already a benefit from that. And this part of your small enterprise, your small shop is already running on it. And then the next part, well, this week you do it by hand, and next week I will program that part, and then we can have it all running with computers. That's the point. We are using agile software development for that. So we will start with small functionality, and each day we will add more functionality to it, or each week we will add more functionality, and our system will grow over time each week. That's the idea. We will use, and hopefully, no, we are through with this. We have to go for the Discord. We go into here. This whole course is going to run on TypeScript. So who already knows TypeScript? Anybody? So you people in Douala, what is your first programming language? Can you put it on the chat? Which programming languages you do already know? Java, great. Anybody with Python? C++? Fortran? COBOL? Rust? JavaScript? Okay, Java is great. Java and Java again. Okay. Flutter. Oh, Flutter is cool. PHP is not a programming language. JavaScript. Oh, very good. Okay, there are a lot of languages known already. So we will use TypeScript in this course. TypeScript is a variant of JavaScript, and it's a very lightweight thing. And the idea is the programs that you are going to build shall run on usual hardware. We do not want to build software that requires you to buy a fat, very expensive computer. Ideally, you shall be able to use all these things with your smartphone. Anybody have a smartphone? So who has a smartphone? Yeah. So there you can have a browser on the smartphone. And we assume that many of the people in Cameroon have a smartphone, and you actually can do the shopping and that many of the people that are actually participating in this whole work can have a smartphone and can enter the data through their smartphone. That's the idea. So the device that people will actually use is a smartphone, and then your usual PCs should work as the server. So if you have a small enterprise, some 10 people working there, you put one computer in the corner, you have some smartphone, and then your customers can come, can order, can pay through the smartphone, and can actually, and you can deliver the people that actually deliver the goods have a smartphone, they get a message on their smartphone, they bring this thing to the people, and that's what's to be done. Okay? And then Amazon is out of business. Or you finally have something like Amazon at Cameroon. So that's the idea. So we chose, or I have chosen to use TypeScript here to have very low requirements on the hardware that we use. And actually, it turns out that TypeScript is not only very good to run on the smartphones, but also on the servers. At the server side, we will need or use Node.js. Usually, so we have to say this, in your browser, on your smartphone, there runs a JavaScript interpreter, which is actually something like a virtual machine or a little computer in your browser that executes the JavaScript program or the TypeScript program. And and in our approach, we will program the server also in TypeScript, because then it turns out that TypeScript works at the server side very well too. And it has very low requirements on the hardware, and it is very efficient and fast also. So usually you would implement the server in Java, but it also works very well in TypeScript. And what you need to install in order to enable this is Node.js. And Node.js is a virtual machine to execute JavaScript and TypeScript. And it's actually a small browser just with a headless thing. It does not show a graphical user interface to you. It just runs without a user interface. But actually, it's just the same virtual machine executing the JavaScript or TypeScript programs that you would use in the browser too. And it's very fast and very efficient. Okay, so we need to install that. And we have prepared in the Discord. And you should go to the Discord and go to the boarding. Quite a list of things that we would ask you to install on your computers. And we need a number of things. You need to have Zoom to participate in these lectures. Cool. Here it says IntelliJ, WebStorm, and Docker. That's no longer true. Let's get this one out here. You just need Visual Studio Code. You should have a webcam. Yes, you have. That's great. Visual Studio Code. You can download it from here. Just go into the Discord, click on it. If you do not, who has Visual Studio Code? Know that. Yeah, some hands are raised. Great. Cool. That's fine. We will run this on GitHub. So we please ask you, create an account on GitHub. Who knows what GitHub is? Okay, who has an account on GitHub? Also, great. So we will actually use GitHub Classroom to do assignments, and then just a single one actually. And then this creates a GitHub repository and gives you and us shared access to this repository. And then we can actually, well, check out your code and dig into it and help you on that if there are some problems and these kinds, and we can collaborate on that. Each of you gets her or his own account or GitHub repository after all, and we will use that for grading your homeworks. GitHub. You need some client to run with GitHub, so you all know Git. I use Git Kraken for that. You can use whatever you want. Node.js, download from here. Current version, I have no idea. It's, Sebastian, which version is out now? Version 14 would be great. I did not yet do that myself. I'm still on 12 or something like that. We would like to ask you to go to this link here to Google, where is the Google form, where you could register for this course. We just need your name, your email, and your student ID. Matriculation number is actually a pretty German phrase. This means your student ID. If you fill that form, we will collect all this into a spreadsheet, and actually we'll put the grading that we do on that spreadsheet. And at the end of the term, we will use this list to send to University of Douala to Mr. Fono, so that Mr. Fono can actually print or give you your credits for this course. So in order to get credit in this course, please fill out this form so that we have your name and your student ID, and that we can give you, so that we can sum up your points in this sheet, and in order to submit it. So this is just for, please, we need your name and your ID in order to attribute your things to your name so that we know that we are doing the right thing. Okay, this was the registration. Yet again the link to the slides. Then there is GitHub. Here you can actually open the GitHub Classroom project. I already did it. So this will say, oh, you already did a go there. If you do not yet have a GitHub account, they will ask for it, and then this is achieved. Okay. So you finally have to upload your homework to these repositories, and then we can have a look at it and we can grade you on it. In addition to demonstrating it to us. So that's pretty much it. What you should do is, once you have downloaded your GitHub Classroom assignment, you should run this line in Visual Studio Code. So what you actually should do is, you should open Visual Studio Code. Come on. I would like to make this a little bit bigger. Yeah. It did it. Please. Yeah. Yeah, great. So this is my Visual Studio Code is already running. You have to open a terminal and you use this thing here. I should go up. And that's not good. Go into your project directory or create a project directory. Microservices 2021. And then you execute this program. You first have to install Node.js. Then it should come with this npx. You execute that. It will take ages. This is going to download a ton of TypeScript things that are used for the application that we are going to do. And depending on your internet connection, this will take some 4, 5, 6 minutes to half an hour to half a day, something like that. So please prepare this before the next lecture so that you have this already done. So this will take, quite some time. And how do I go to the other terminal? No. More left, more right. The other left. I think that one. Okay. So I have already prepared that for you. And if you have done that, it will download a lot of things for you. Will you get something like a directory, which is called a web shop? You actually open that directory. In that web shop, you have a lot of TypeScript things, and we will go through these things next week on Monday, 12 o'clock. And basically, what you can do in this web shop directory then is you could do an npm. So it's npm start or run start. So npm is the command that comes with Node.js. which is the Node package manager, which is used to execute all kinds of stuff. And we use it to download a lot of things that you need and then to execute these things. And if you start that, it says, oh, I'll start the React script. It probably will, again, download a lot of things. And then it should open your browser and show you this first page here, something like that. And please, would you prepare this before Monday that you are able to start this example application. And then we will start to dig into this a little bit deeper. How do I close this thing? I have no idea. Yeah, did it. Yeah, okay. So here's the program that actually generates this page here. And we can actually say, oh, let's change this and say, hello, Douala. That's not the D-O-U-L, Douala? Is this right, Eric? Okay. So if I save this, there's an A missing, Douala. Thank you. So if I change this, look here, the web page automatically updates. We can actually code in here, and here we already see how is our application working now. And that's actually pretty much the setup that we will use to program our application. One of the very first thing, and perhaps a good homework for tomorrow, for Monday, is get rid of this black color. It's really ignoring. And you figure out how this is done. And I will explain it actually to you on Monday. I should explain that. When I was learning programming, it was at the end of the 80s. Eric has a question. Yeah. Yeah. So what I ask you to do to Monday is go through all the steps of the boarding, download Visual Studio Code, and then finally, okay, I need the terminal again. How do I get that one? It was, no, give me a terminal. Okay. And what I would like that you really, no. We get it. No, oh, no good. I go for the boarding here. That you have Visual Studio Code. You have the GitHub Classroom repository. So you go to GitHub Classroom, accept the assignment. You download the repository on your local computer. You open the repository. In the repository, you open a terminal, for example, within Visual Studio Code, and you run this line of code, which is no npx, node package execution or something like that. I have no idea. Create React application, which is actually going to set up your project, your TypeScript project. Sorry. And then you give it a name. And the first project that you are starting with is going to be a web shop. And we want a web shop that is based on TypeScript. So if you do this, this will take some 10 minutes or an hour or something like that. it is going to download a lot of things and set up your first, well, TypeScript project. Then you open that project with Visual Studio Code, and you go into, actually, that should have created a directory called web shop within your project. You go into that one and you do an npm start. And if everything works, you will get this thing here. So your browser is open and you have a running React program that shows this page here. And then you can actually go into your Visual Studio Code, change something of this example page here. You actually go for, there should be a file which is called app per application. TSX, TS is TypeScript, and X is an extension of TypeScript. I have no idea what the X is good for, Sebastian. It's an extension which allows you to write templates for HTML pages directly within your TypeScript code. And that's not what I wanted. Go away. And then you try to find the hello, which is down here, and then you put something in here. And if it works, it will update the web page. And then you're ready. So prepare this for the next lecture. Okay? There's one thumb up at least. Great. So, and then we will actually spend Monday in order to come up with the first parts of our web shop in order to enable actually some of the people working at the warehouse to add goods to our store. And that will be the steps that we are going to program on Monday. Okay? So, I hope you, well, enjoyed the lecture. You could actually do some of the reactions. I would like to see some clapping hands and thumbs up and cheering and whatever. And I hope this whole thing sounds interesting to you. And I hope that we actually have a lot of fun during the next weeks in building up this application. And I'm really looking forward for this collaboration with you guys in Douala. And I will hope that this will be a quite nice experience and a lot of fun to do this. So please go through the boarding and we will see on Monday at 12 o'clock. And yeah. Yeah, okay, cool. So, if there are any difficulties, just go to the Discord and add any questions and try to contact us. We will have an eye on the Discord, and if there are some problems you cannot deal with, contact us on the Discord, and then we will give you a helping hand. Okay? Okay. So, see you on Monday. Thank you for your introduction, for your attention.